Okay, so before we get started, I'd recommend that you go to the video description and grab the GitHub link that's in the description. I generally design these to be a walkthrough that we can do together. And so this is video 3 of the Kubernetes in the Cloud series. It complements a couple of other videos that we've done in the past. The first one is the GCP Managed Instance Group, where we took this Python-based microservice using the Flask framework and implemented them on VMs, and then we did the same thing with the same code with containers using Cloud Run to deploy the container as the simplest container runtime. So what we're going to do is in this project we have a fully automated deployment of the Google Kubernetes Engine, and we're going to take that same code that we deployed in the other projects and put it in a container again, and then use Kubernetes as the runtime. And so what we're going to build in this project is several things. The first is the Python-based microservice uses a document database. So in Google, we use FileStore for that. And then we're going to have the actual container build. We're going to build the container using Docker for the Flask microservice. Then we've got 3 other containers that we're going to build, which are primarily just HTML content. And there's some game links that I found, so I do Tetris, Frogger, and Breakout. And so we're going to end up building 4 containers. Then we're going to push those containers into a couple of Google artifact registries. One is for the Flask app, and one is for the games. And then after we build that, we're going to build the GKE instance. That takes quite a bit of time. This is the most expensive part of the build. It's about 10 minutes or so. And then once we have that built, we're going to use the gcloud command to hook up kubectl into our cluster. And from there, we're going to deploy a games manifest and a Flask app manifest, which is going to take those containers and create the service and deployments and ingresses necessary to get them deployed within the Google Kubernetes instance. And so finally, we'll use Nginx to glue it all up together. We have a Google load balancer that acts as the front door into the projects, and there'll be 4 different endpoints that are mapped on the Nginx controller, one for the Flask app, one for the Tetris game, one for the Frogger game, and Breakout game. So that's what we're going to be building in this, and it's designed to be a complete solution, so you can take it and adapt it to your own, but this should work out of the box for Google Cloud. So I guess let's talk about the nature of the Kubernetes services. And first off, I'd like to point out that Google was the people that came up with Kubernetes. So it kind of makes sense that this works the best in Google. It was much easier to implement on any other environments because they're the OG Kubernetes people. And so let's talk about the services. Now, they probably set the pattern, but essentially it's platform as a service. But it's a little different than other platforms in the service in that it transparently uh, deploys infrastructure to implement the service, and you can actually interact with the infrastructure. So that's a double-edged sword. So let's kind of walk through the elements, and I'll contrast it finally with the other platform as services and how it's quite a bit different, but it's still platform as service. So the first part of the Google Kubernetes engine is the control plane. Now this is the fully managed abstracted layer. We don't know how they're implementing it. It's probably VMs, maybe it's containers, but you don't get to see how it's working underneath the covers. You just basically use kubectl, and it orchestrates everything for you, so it's transparent, and it uses an OIDC provider, how you interact with it, but again, you don't know how it's actually working. So from there, we go and say, oh, let's provision a node group or a node pool. Node group is AWS, node pool is in GCP. So what happens? Well, what happens when you do a node pool is Kubernetes on your behalf is going to create a managed instance group. And you kind of describe what you want the instance group to look like, if it's scaling, how many instances, an instance type. But you don't create it directly, you describe it. And once you describe it, then the Kubernetes managed service ends up provisioning these instances. via a managed instance group. And so you can go in and say VMs, you can see the managed instance groups, you can see the VMs, you can see all this infrastructure, but it is managed by Google Kubernetes Engine. And so same thing with the load balancer. The load balancer, when you declare a service for the load balancer tag, it's going to end up creating a load balancer for you. We get a level 4 load balancer in this project. And again, it's transparent. You can go in and see the load balancer. You can see the attributes of the load balancer. And so among that is if you go and start looking at all this infrastructure that gets provisioned on your behalf, if you look at the labels, you'll see all these labels. The other platforms call it tags, but there's all sorts of labels that have the bookkeeping for Kubernetes. So it'll, tag what cluster this is a part of, what node group or node pool. And so we'll look at that when we build the solution, in that you can see that the bookkeeping is all done by tags. Now, there's a double-edged sword with all this stuff. I can see this infrastructure, I can interact with it, I could go mess up the labels, I could go, do all sorts of things because you can transparently see the infrastructure. Now, the benefit is if I want to customize the infrastructure, if I want to do some things that they didn't think about, I can do that with this, but you have the risk of breaking things. So finally, this is a managed service, but it has sort of an infrastructure as service twist to it, and that you get the infrastructure that you can see and you can interact with it. I would say, compare it to like the managed Active Directory service or Firestore or any other managed services in GCP. They provision infrastructure for you. Like when you do Active Directory, it's going to have 2 VMs as domain controllers. Well, you don't see those DMs. You can't interact with them. You don't know their attributes. And that's where this offering is different. It provisions infrastructure and allows you to see them and interact with them, which has that dual-edged sword of I can customize to a great degree, but I also can screw it up if I do the wrong thing. So that's the nature of the services, and they're very similar across all 3 platforms. They work the same way, and manage infrastructure the same way. And like I said, I think Google probably set the pattern with this, and the other providers just copied it. That's kind of my guess. So let's go through the solution. So let's go through the solution diagram of what we're going to build. And the first one is the Kubernetes view. And the Kubernetes view is starts with the control plane. This is the fully managed abstracted layer. And for all intents, there's many different services. I just highlighted some of the key services. And then we're going to use kubectl into the API, and that's how we're going to interact and run things. So in addition, we create 2 node pools. We got the default node pool, and I believe it bursts like to 4, or maybe it's 3. I'm not sure the exact number of it. I think it bursts up and down. So we got the default node pool, and then we have the games node pool, which is just one node as we've defined it. And that's where we run all the games. And we put them all in one node pool. Then we have the VPC. We have the connected GCP services. The first one is the VPC networking. We've got the artifact registry. We have 2 of them, one for the Flask apps and one for the games. Then we interact with the Firestore database. And to do that, we create a Kubernetes service account and attach it to these pods or this deployment. And then it can these Flask apps can interact with the Firestore database. And then finally, you've got the level 4 load balancer paired with Nginx. Nginx is a level 7 load balancer, so we're going to define things on the load balancer path, like there'll be a path for Flask app for the API, and then there'll be a path for games, and that's all managed between the level 4 load balancer and then the level 7 layer on top of that Nginx provides. So that is the Kubernetes view of what we're going to build. But we also need to look at what is the infrastructure. Like if I go into the console, what am I going to see? We're going to see, first couple of things is you're going to see the artifact registries that we created, the table, the Firestore table. But the more interesting thing is the infrastructure that Kubernetes deploys for you. And first of all, if you've got the managed instance group, which manages the node pools within Kubernetes. And so the Flask app, what they want, they scale up and down, I believe up to 4. And then finally, the game nodes It only has one, but it's still a managed instance group. So you get a managed instance group that has one and it never scales up. So that's the infrastructure that actually gets provisioned, and what we're going to do is build a solution, look at the logical view with Kubernetes, and then look at the infrastructure that is deployed on your behalf. Okay, so let's talk about the prerequisites that you need to have in place so you can actually build a solution. The first one's pretty obvious. You have the Google Cloud account, but we also have the G-Cloud CLI, the Terraform, as far as Terraform. We'll use Postman for testing, and then we need Docker. Now, I'm building this in an Ubuntu Linux environment. So if you're doing it in Windows, you're going to have to make some changes. But if you do Linux, Ubuntu, or really any Linux environment, you should be able to run the scripts that we've provided as is. Now, we also have a video we did a while back called GCP and Terraform Easy Setup. That walks you through a very simplified solution just to make sure that you have all the plumbing hooked up so you can do Terraform builds. It creates a VPC and then puts an instance and, and then you connect to it. So if you've never done one of these videos, this is a good starting point. It's very simplified. You don't have to worry about the complexities of Kubernetes. So at this point, I'm assuming that you have all these prerequisites met. So we're going to start the build. So the first thing we want to do is we want to copy this and go to your development environment, paste it in. Now, first thing we're going to do is we're going to run check env. And it's going to say, hey, you don't have credentials. So if you go back to that video, you have to take your credentials you get from Google and you put it in a credentials.json file into the root directory, and then it'll work. So let's upload that from my laptop. So I'll go into the project here and upload, and there's the credentials. Let it upload, and then we're going to have to do check env. And that works. Now, the other thing you got to do with Google, of course, you've got different APIs you have to enable. So I'm going to do API setup. So we have a script that updates them. I do that in a script instead of a Terraform because Terraform, when it destroys, it just gets weird in a weird state. So I usually do my APIs in a setup script. But you can't do it in Terraform. If I just find rapid development, you end up in these weird states where it's unregistering. So it's installs. It also installs this auth plugin for you. And now we are ready to run the build. So I'll do clear, and I'll do apply. And what I will do is give you an overview of the build, and then we'll wait for the build to finish. So the build has 4 steps. It's very similar as to the other builds. The first step is we're going to provision the artifact registries. We create the Flask app registry and the games registry. And that allows us to go to the second part of the build where we're going to build the the microservices and everything with Flask containers. So that's going to be 4 containers that get built with Docker and are pushed into the artifact registries or repositories. I always get registry and repositories confused, but it pushes them into the where Kubernetes can actually access them. Then the third stage is we're going to deploy the Google Kubernetes Engine cluster. We're going to have 2 node pools, the Flask nodes, the game nodes. That's what's going to result in the managed instance groups. And then finally, the 4th step, we're going to glue kubectl. There's a gcloud command to glue it up. And at that point, we can interact with the cluster sort of in a Kubernetes agnostic way. And we're going to deploy the 2 YAMLs, the Flask app YAML and then the games YAML. And then at that point, the services will start up. Then the endpoint should be active. So at this point, what we need to do is wait for the build to finish. Okay, so the build has completed. So let's go take a look at what got built in the GCP console. So I'll bring up a web browser and go into my GCP account. I'm on my debug project. And the first thing I'm going to do is I'm going to type in Kubernetes, and it'll say Kubernetes Engine. So I'm going to go look at the instance that got created. and it's running. It should have 2 nodes. And scale down block by pod, don't worry about that. That is a message from yesterday. I discovered that if you create a GKE instance and destroy it, it retains the log. So I was working on something yesterday, and it's got a bunch of stuff from yesterday. So that's an interesting sort of aspect of GKE. The other ones are completely independent, but I imagine that's just an issue of use the same project and the same name, and it tries to retain things. So let's drill into this instance. And we've got the main page. We've got the cluster basics, which is everything we put in the Terraform. We're running 131. I think we just said give me whatever is the default. I think 131 is, I don't know, we'll talk about the Kubernetes version process at the very end. But that, I guess, that gets us to the end of the year, and the extended support is 2026. So then we've got the networking. We've configured this so the control plane is public. I don't think you would ever really do that in real life, but this is just an easy way for us to interact with kubectl without having to worrying about any virtual or some VPCs or virtual networks. So what we're going to do is now look at the networking. We're using our VPC that we've created. And it can give you a IP utilization. We'll talk about at the end about how you need to budget IPs a little bit differently for Kubernetes. It's you have to have a IP address per pod, which means that you need to keep that in mind when you're creating your VPC to give enough CIDR blocks for it. And then we've got the nodes. So the nodes here are we've got 2 node pools, the default node pool and the game node pool, and at this point they all have exactly 1 instance each. And at some point we're going to scale these up. We're going to overload the pods and watch it scale up and watch it scale down. We also have logs in here, which is pretty cool because it feels like rooting around the logs. It also feels like you're rooting around the dumpster for Kubernetes. There's tools like Grafana and stuff that will make it easier, but they have like a first pass. The other platforms you have to pay for, Grafana or maybe Prometheus. There's several of these tools for getting through all the logs and consolidating so you can search them. So that's for the general. Now there's also something called Object Explorer, and this is much like the other platforms. They have like a kubectl interface within the console. So this is essentially what this is here. So I can go in and say, all right, my namespace is games in default, and I want to list, let's say, not ingress, but let's list pods and maybe deployments and hit OK. And it's going to show you all of these. You can drill down on them. Now, I typically interact with Kubernetes with kubectl, so I'm not sure how many people actually use these on a regular basis, but it's just a quick way of getting in and seeing what's there. And you could go in and filter by certain namespaces. You can click on it, it'll give you more information. But again, this is probably like a describe. Ooh, they got observability, so that's pretty cool too. Google is just so much better than the other platforms and out-of-the-box functionality, and here's another example. So we've got this all working, and I think I've covered the kubectl equivalent. Now what we're going to do is we're going to go look at the what the infrastructure that got provisioned. So the first thing we're going to do is we're going to go to VM instances, and you're going to see the 2 nodes associated with the node pools. So those are the ones that get created. I was going to drill down into one of them and show you all the lovely tagging or labeling. So if you go look at the labels, this is all that glue connective tissue that connects all these services together. You can see it's got its own set of labels that allows Kubernetes to keep all the books straight. And that's also true on, like, if I go to an instance template, which is like a launch template, same deal. It's got all of these things in there. So let's look at, so that's the tagging that we've talked about. This is the infrastructure that Google provisions on behalf of Kubernetes. And then the instance group is sort of the other big issue with the infrastructure that gets deployed. And so each node pool ends up being a managed instance group. So we got the default node pool, then we got the games node pool. So that's what gets provisioned. It's very similar to the other providers. Um, let's go into load balancing, and the load balancing also will show you the load balancer that Nginx provisions. It's a network level 4 load balancer. It's interesting though because I was expecting it to have labels, but it doesn't have labels. So that is a little bit different. I'm not sure how it's keeping things straight. Maybe it's a weird name. I don't know. But in any event, this is the last part of the infrastructure that gets deployed. And I guess the other thing we'll look at is the Google, I guess it's the artifact registry. And that's where we are putting all these container builds. So there's a Flask repository and there's a game repository. And that's where we're storing those Docker containers where we built with Docker during the build. So I believe that's it for the console tour. So what I'll do is, I think next spring we're going to go through and look at all the endpoints. So what I'm going to do is go back to my, here I can do validate, and it should validate there. I'm going to copy this URL, and I'm going to go back to, I'm going to bring up Postman, and in Postman I'm going to put this in there and say, all right, give me the API. And so you'll get the same endpoints that we see in all the other ones, where it does connected. The host name is really the IP address of the pod. You'll notice the Flask app API path element. And now we're going to test the other endpoints. So I can say API candidates, and I should get, oh, this is interesting. It remembers it from yesterday. So that's all the candidates. So now I can do a post, and I can say homie2, and I'm going to get homie2, and then I can go back to candidates, and I should now see all three of them. So we've got that. The only other endpoint is there's a get on candidate, and I could say homie1. And so those are the 4 endpoints of the Flask API that we have developed. So that's one path and what we've deployed. The other one is, let's go to, I'm going to copy this right here, and we're going to go back to the browser, and we're going here, and we're going to do Control V, and you should get an Nginx error because we don't have a path. So now I should be able to do, remember before it was Flask app.api, GKE. So that's there. So now I'm going to do games, Tetris. And we got Tetris going on here. And Frogger, which, you know. I don't know why I feel the need to win every time here, but that's Frogger. And then we have Breakout. So this is the what the end user gets for all these containers that we've deployed and created service and deployments for within Kubernetes. So those are the 3 endpoints, or the 4 endpoints, because the Flask app is the 4th one. And so now what we're going to do is we're going to go back to the shell here, and now we're going to start using kubectl. So let's do kubectl get pods. Alright, we got kubectl get pods. How about kubectl get pods-d games for the games namespace? There we have the games, and then I could do kubectl describe pod, and you get that. And at this point, you're in Kubernetes land. So it's going to seem very similar to the other ones. There's simple differences about what image to pull in, and then there's some other environment variables but that they set for you, but for the most part, this all looks the same between the providers. Um, so let's do kubectl get pods. And actually, it's kubectl get nodes. And you can see we have one in each one. So what I'm going to do is I want to overwhelm the cluster. And I'm going to kubectl apply -f stress.yaml. And if I do kubectl get pods, you're going to see kubectl describe pod on this one here. And it's going to say, hey, I don't have enough nodes. So it's what we're going to do is we're going to wait. So if I do kubectl get nodes, we're going to wait, and while we're waiting, you should be able to see, if I go to VM instances, and you can see it's already started to scale up. It's not done yet, but what we'll do is hit pause here and let it finish initializing, and then we will see what happened with the deployments that we put in with stress.yaml. I am constantly surprised with how quickly the scale up happens with these Kubernetes environments. So now I've waited like a minute, and if I do kubectl kubectl get nodes, you'll see, hey, there's now 3 nodes in the default node pool. It could go up to 4, but we only needed 3 for my stress test. So if I do kubectl get pods, all those ones that were pending are now running. So let's see, this should have the old one in there. And you can see it waited for a new node to come up, then it scheduled it and put it on that node. So this is all working as expecting for scale up. So what I'm going to do is I'm going to do clear, and I'm going to do kubectl delete -f apply stress. And what's going to happen here is my node should go away, or my pod should go away, and we're going to wait a few minutes and go back to the console. This should eventually scale back down to only 1 node in the default node pool. So we'll wait for that to happen. Okay, so after about 10 minutes, you should see the number of VM instances go down, and these are the number of nodes. So we're back to our starting position, which is 2 nodes, 1 for each node pool. So 1 the default node pool and 1 for the game node pool. So if we were to go back to kubectl and say kubectl get nodes, you should now see that you just have the 2. So we watched it. We put in that stress YAML. So this is just a very simple running this image here, and you can use that to overload your nodes and have it scale up automatically. Then you turn it off, and it should scale back down. So at this point, we've done everything we want to do to demonstrate this cluster. This is a complete working example, hopefully, for you. You can take this, you can adapt it, you can make it your own, you can build your own containers, deploy whatever. I hope this is a good starting point for if you're trying to do Kubernetes in Google. And so at this point, what we want to do is we want to be good stewards of our cloud accounts. And I'm going to go ahead and do destroy. While it's destroying, I'm going to go through some of the Google specific issues with Kubernetes. So like on my other videos, Google is just easier. It was much easier to get up and going with GKE. I think that makes sense because they are the origin of Kubernetes. Kubernetes is a Google project. They were the first one to have a managed service. They kind of set the pace for this technology. And I was talking to a colleague, and he was saying that he considered Google sort of the Apple of the cloud providers. It's got a higher quality. It may not be number one in terms of number of users or revenue, but it's setting sort of some of the standards like what Apple does with usability and the form factor and everything Apple did with the iPhone. They're kind of doing that with the Google Cloud. And I thought that was a fairly decent analogy. They're really kind of the premier sort of high-end cloud provider, as near as I can tell. Another issue, and this is true on all of them, is the CIDR budget. You need to remember that when you run Kubernetes, each pod gets an IP address. So a lot of times you're negotiating with a client about IP address ranges. Don't just think about your VMs. You now got to think of number of pods. So if you have thousands of pods, and I've seen applications with thousands of pods, you need thousands of IP addresses, which can make it difficult sometimes negotiating such a large range. But that's just what Kubernetes does. The auto scaling and the load balancing just works out of the box with Kubernetes. With the other providers, you have to sometimes install Helm charts to do that. The only Helm chart involved in this project was installing the Nginx extension. So they all work out of the box. We've demonstrated you scale up, you scale down. The load balancer that gets created, it's a level 4 load balancer. The way it works in AWS and GCP is they use a level 4 load balancer infrastructure, and then they bolt Nginx on top of it, and Nginx becomes the level 7 load balancer, application HTTP load balancer, where you can map paths to specific containers and do some nice things like that. Okay, this is an annoyance, but you'll notice, like in we have to use an IP address here. So we're doing some stuff, some fuckiness with public IP address that you normally would not do. So Google doesn't put a lot of thought into making this pretty, whereas the other providers, you can get a DNS record within the cloud provider's domain, so that this shows up as it's a really ugly DNS record, but it kind of helps with development, because I'm in my corporate environment. I can't even go to this URL because it just assumes that you're up to shenanigans if you're trying to navigate to a HTTP endpoint by IP address. Now, the reality is, what you would do is you would have your own domain records. You use Cloud DNS and create a CNAME, or actually it wouldn't be a CNAME, it would be an A record into this IP address, so you could use that. But Google was like, yeah, that's janky. We're just gonna give you the IP address, and you worry about doing the DNS lookups within Cloud DNS. So that's one thing that kind of irritates me. I kind of like the way AWS and Azure will give you a DNS record within the cloud provider's domain space, but they don't do it, so it is what it is. Finally, the support cycles for Kubernetes. Each Kubernetes release, I believe this was built with 1.3.1. It has a 12-month plus a 2-month support period. And so you get that, I wouldn't say for free, but you get that for the default cost. And then after that, Google will give you an extra year of support, or you just get the basic security fixes on your cluster for another year. So you can support these for 2 years. Now, it costs extra. I was reading, it looks like they have the exact same cost structure with AWS, in that it's 10 cents an hour for the control plane in GKE, but then when you go to extended support, it's 60 cents an hour for the control plane. So it's a pretty significant cost increase for the control plane, but in the grand scheme of things, there's so many things that cost more than that. Just network ingress egress fees can kill you in some platform providers, and then if you're using any sort of high value storage like NetApp or any of the other enterprise grade storage solutions, that's going to be a huge cost. But in any event, it says also at the end of the 2 years that, actually I guess it's 26 months, that they will automatically upgrade you. Again, I've never seen that. I've never gone that long. One of the challenge for if you're in a highly regulated industry is these support cycles seem long, but for something where you have a long SDLC cycle and you have months before you can deploy something new, like a version upgrade, because you got to do all these testing, it kind of becomes a pain. But I have had some clients that have servers that have been on for 10 years because they don't want to touch it because it's been validated appropriately. So you kind of have to dispense with that. Run this thing forever. You're gonna have to upgrade at least every 2 years, but you probably should have a yearly cycle where you upgrade, because that way the changes don't accumulate and it's like 2 years. It's like, oh my God, everything's changed. Usually the control plane upgrade's fine. It's the node groups that cause you issues. And every upgrade I've ever done has had some sort of like head scratching thing. So when they say just click here and upgrade, it usually ends up with a small fire that you have to put out first. Okay, that is it for the Kubernetes in the cloud series. This is the Google Cloud version. It's the OG. I think it's probably the best cloud provider overall. And that's it for this series. Thank you.